In this lesson, you'll learn how to add and subtract fractions with common denominators. Fractions that have the same denominator are called common. We refer to them as common denominators. Or we could say like. They're like fractions. You've heard me say in the past that we're going to compare like fractions or unlike fractions. So the denominator is what we're referring to. When you say common denominator, it means they have the same denominator. Remember, the denominator is the number downstairs. The D will help you remember downstairs. So for 8/10, the downstairs number is the 10. That tells you how many pieces the whole is broken up into. When the denominators are the same, add and subtract the numerator only. So in this whole lesson, the denominators will be the same. So all we have to do is add or subtract the numerators. The first strategy we're going to use in order to learn how to add and subtract fractions that have common denominators is using our pattern blocks. So we'll get out our pattern block. This is going to represent one whole. We want to compare it to this the whole time. It's kind of like your mat that you want to lay it down and compare it to make sure that you don't go over this hole, or make sure you don't have any spaces in this hole. So I've already drawn my hole, my hexagon, and then it says 2/6 plus 3/6. Now I've broken it up into 6 pieces, or with your hexagon you have 6 triangles. So if I were to place the triangle onto the hexagon and I line it up perfectly, there's 1, 2, 3, and if I keep going, I know that 4, 5, 6, there will be 6 that fit perfectly without having any space left over. They fit perfectly. Nothing's hanging off the back, and I would fit 3 more on there. So I've done that on here to show. So if I start out with 2, so I put 2 on my mat, on my manipulative. Okay, so I have 2. It's kind of hard to hold it, but you'll have this laying on your desk. So if you start with 2, you're going to add 3 more. Now you started with 2, you added 3. I'm only representing the 2/6 on this side and the 3/6 on this side. So now what I'm going to do is I'm going to add only the numerators. This little friend here tells us if you're adding or subtracting, the numerators only, no matter what, because the denominators are both in the 6. They're both broken up into 6 pieces. All I have to do is add the numerators. So I know that 2 plus 3 is 5. And this numerator slides over and it stays 6. Because I can see that I have 1, 2, 3, 4, 5 sixths total. That's my sum, or my answer. If I look at the next example, I see it's broken up into thirds already. Or for my hexagon example, I could break it up into thirds. So I have my 1 whole, and then I have my 1/3. 2/3, 3/3 would fit right on there. So if I start with 2/3, oops, I'll just use blue or green. Start with 2/3, okay? 2/3 minus, now I'm going to subtract this 1/3. So I'm representing the picture on top of this. When you're working in class, you may see the picture that goes with the number, or this equation might not even be visible. You might only see the 2 pictures. So 2/3 minus 1/3. Well, if I remember the numerators only, I need to subtract only the numerators. 2 minus 1 is 3, or 2 minus 1 is 1, not 3. Now, you want to keep the thirds because you're still going to keep it into 3 pieces. You don't want to change that. So if you were to keep and show it in a picture form, you have your thirds. You want to do your best drawing it equally. And you started out with the 2, then you erase the 1, you end up with 1. Or if you just cover all of this, you could have erased one of those and you're left with the 1. So that's with pattern blocks. Another strategy is to use your fraction bars. So, okay, again, we have our 1 fraction bar. It represents one whole. Just like with our hexagon, this represents a whole. This bar from one end to the other end is one whole. So if I have 6/12 plus 4/12. So over here I'm going to color in 6/12. And I could get out all my 12ths. They're very tiny because the bigger the denominator, the smaller the fraction. So I have 6/12. So let me color in 6. Okay, plus 4/12. 1, 2, 3, 4. So I don't even, those aren't used. I'm only using the shaded ones. So if you were to lay these on your desk, these wouldn't be here at all. You would only lay 10 altogether. You'd lay the 6 and then you would lay the 4. So now you have the numerators 6 plus 4 is 10. The denominator stays the same because you want to keep it in 12 pieces. You want those pieces to be equal. Our little guy here tells us adding or subtracting. You're going to add or subtract the numerators only because the denominators, the 12s, are the same. If we look at subtracting, if we have one whole as our guide, what to compare it to, start out with 4/5. So if you take your little fifths and you slide up, you got to slide up 4 of them. Now you're going to subtract 2/5. So you're going to subtract 1, 2. How many are you left with? You're left with 1, 2, 2/5. Again, the size does not change. It stays in the size of fifths. You don't want to change the size. You want those denominators to stay the same. A third strategy that we can use to add or subtract fractions that have a common denominator is our number line. We can use our number line to add or subtract fractions. So for this one, the operation tells us to subtract. So we're going to start with 5/6. Here it is. We're going to subtract 2/6. Now I'm not going to go all the way over to 2. I'm just going to go back 2 spaces. So 1, 2. And that would be what we call half, or what is equivalent to half is 3/6. And if we check it, 5/6 minus 2/6. 5 minus 2, we remember to subtract only the numerators. 5 minus 2 is 3. And keep the size the same, 3/6. If we look at the next one, 1/8 plus 6/8. Start at the 1/8. And we're not going to go to 6/8. We're going to add 6/8. So you're going to add 6 spaces. 1, 2, 3, 4, 5, 6. So 7/8 is your answer, or your sum. 1/8 plus 6/8 is 7/8. And hopefully you're starting to see a pattern. The numerator gets added, the denominator stays the same. It has to stay the same size. You cannot add 6 plus 8 because they would not be equal fractions. Do not make that mistake. Make sure you're not caught making the mistake of adding the denominators also. So let's say we did add the denominators. 7, it would be 7/16. So then we're going to have to break it up into even smaller pieces. And so the answer would be 7/16. 1/16, 2/16, 3, 4, 5, 6, 7/16. Is that the same size? Absolutely not. Do not add the denominators. Miss Prophet likes to say, Dad, D-A-D, don't add denominators. So we'll keep our answer as 7/8. So if you want to do it the way you will in 4th grade, you'll say, Dad, don't add denominators. The 4th method is a fun method. Just like with our butterfly method to compare, I have a caterpillar method to add and subtract. And this helps you to remember only to add the numerators. Only add the numerators. So if we have 2/3 minus 1/3, now we're not going to dad or anything like that. We're going to forget about those denominators and keep them the same. We're going to keep it the same because Dad, don't add denominators or don't subtract. You could say DSD, don't subtract denominators. Either way. So now you have your caterpillar. All you have to do is draw his little legs, his body, and there you go. You got a precious little caterpillar, and it shows you to subtract only the numerators. 2 minus 1 is 1. Same thing here, 7/10 plus 2/10. The denominators are the same. 7 plus 2, we know we're only going to add the numerators. So we can draw our caterpillar for to help us remember. So 7 plus 2 is 9. The last one, 9/12 minus 1/12. Now we keep switching back and forth from addition to subtraction, so we want to make sure we look at the operation. We draw our caterpillar, and you can get as fancy as you want, or as simple. You have 9 minus 1 is 8. Then 12 minus 12 is 0. Don't subtract denominators. So 8 zeros, that doesn't even make sense. We want to keep the denominator 12. Make sure you don't subtract denominators either. All right, here are 4 methods that you may use at your leisure, or whichever one was your favorite you may use in class. And hopefully we'll be able to explore all 4 in class to add and subtract common denominators.